Justin is one of our developer advocates here. If you've already started RU101, then you'll have seen a lot of fun videos from Justin in that course. And also go and check out our YouTube channel as well, because Justin's made loads of videos in the 2 or 3 years that he's been at Redis, and they're always really fun. So yeah, definitely check that out. I'm gonna hand over to you, Justin. I've already covered like why we're here, what we're covering today, and how these streams are going to work. But just for a reminder for anybody who has just joined us, these streams are not meant to replace what the course material is. So you still need to go and log on and enroll at Redis University if you want the certificate. These are just a supplementary thing. We just thought it'd be fun to kind of have somebody to learn along with you. And also, if you ever have any questions, then just join the stream each week and just come and ask us the question, because Justin's heard everything. Justin's heard every question. He's going to know the answer. Like, no pressure, Justin. But yeah, also join us on Discord as well in between the streams. So yeah, over to you, Justin.
Cool. Well, thank you. Hopefully you watched a little bit of last week, week 0, and we were doing a quick setup and just an absolute introduction to what we're going to be learning this week. But I just want to do a quick kind of review on the basic concept of key value pairs. So a key value pair is the basic storing structure of most databases, and especially with Redis. Key is some arbitrary name that you give for, say, like a locker or a cubbyhole or a location where you want to store very specific data. So a very rudimentary example would be key value would be name Justin. So key would be name. It's just some sort of arbitrary word that describes what it's going to be storing. And then Justin is going to be the value. So instead of key name value Justin, we could do key name value Suze, or key name value Simon. The actual value is, you could think of as possibly the volatile data that changes, but it's always stored at a location that is labeled as name. So we could have a key of weather value sunny, or key temperature value 23, something like that. So let me see if I can. I have to verify that my internet is all back, so I want to make sure that I'm connected to my Redis Insight. Let me just show you really quickly. Sorry. And okay, cool. So let me show you really quickly just a key value store in Redis Insight. So Redis Insight is our browser-based interaction tool with our Redis Cloud instance, or our local Redis instance. But in this case, we're using a Redis Cloud free instance. So a key value store. Let's try. Well, I just said name and Justin. So let's do set name Justin. And it's that simple. So now there exists somewhere in the cloud, somewhere in this world, a memory location that contains the value Justin. And to retrieve that location, that memory value, I would use the name. So let's call get name. And there we go, Justin. And this is actually a really good segue, because now we just introduce ourselves to strings. So strings are just that. It's a data type where you can contain text. So it could be numerical, it could be a paragraph, a poem, a love letter, or an address, or a full name, or anything like that. You can also store binary data. So you can actually like compile down or decompile an image or an MP3 to binary, and you can actually store it as a string. That's a little advanced. For now, all we're really going to worry about for week 1 at least is going to be storing text values as a string or numerical values as a string. So another cool thing about keys, just before we get fully into strings, is that you can set a key to expire. Now, basically, as soon as you create that key, you can say, hi key, hi little entry in my database, you're going to survive for about maybe 5 minutes. And unless somebody updates your time to live, you're just going to gracefully expire and be deleted from my database. So that might be kind of counterintuitive. Why would you enter data into a database that's just going to go away? Isn't a database supposed to be a base for data? Well, there's a lot of different utilities for that. So right now, the weather outside is sunny, but it's only going to be sunny for an hour. Sometimes weather just changes, especially in Oakland. We're kind of protected from San Francisco from the marine layer, but who knows what will happen. So I could actually say that within the hour, my weather will change. So if I set my weather to be sunny, but have it expire in like an hour, that actually would be pretty accurate because I would want to update that value within the hour to see what new weather it is. And this, if you've seen a lot of our YouTube videos, this is an example of caching. So instead of, if you access a website that displays the weather, instead of actually going all the way to maybe in like a SQL database and having it spin up its disk and send back data, Redis can be used to actually check if we have a piece of data, such as the weather, the current weather locally, and that will actually send that data back to you instead of actually having to go all the way to the database. So Redis sometimes is used as an intermediate layer of data that stores updated information. Now, we'll go over this a little bit later. I just wanted to give you a quick little jump into like a use case for expiration. But basically know that all keys that exist within Redis can be set to expire. And to check that expiration, you use a TTL command. And I'll play with that with some strings. Does that make sense so far?
Yep.
Cool,
Totally.
cool.
Yeah.
I had a lot of coffee this morning, so if anybody wants me to like clarify anything in the chat, please don't hesitate. I can see the chat that's going on right now, so I'm here. I'm interactive. So yeah, strings. Let's talk. Let me go back to my my Redis Insight here. Now, strings are cool, but you can create a lot of strings as you go along within your day-to-day work. So we need to actually use a naming convention that's actually really useful, that can be easily recognizable, and you can see what exactly it's referring to. So let's say that we have a website, like a social media website, and we have users. Maybe users follow people, or maybe users are followed by people. So maybe I'll create a string with the key users. Let's just start with that. It just makes sense as soon as you see it. And then when we separate pieces of information that get more and more specific, or use specific ID numbers, we'll use a colon. So let's say my entry in my my profile in this social media, maybe call it Redis book or something. Maybe my ID number is 167249. So I could actually say that's a valid string. Users : 167249. The colon is just a visual separator between what to expect that is inside this key and the specific ID for this key. So Suze might be, instead of 249, she might be 250, something like that. So we use colons to separate data, and you'll see this within all of our different videos for YouTube. Oh, thank you. And I can get even more specific. So this is my actual user profile. What if I wanted just to see a list of people that are following me? So following, or followed by. So this would be a valid string name or a key name. This would be good. Users, specific user with an ID, and then followed by. So this could just store people that are following me, like Guy, Simon, Suze, Kyle, different people. And then, yeah, you saw that I was doing following. So this could mean, this could be just a list of users that I'm following and I'm watching their posts, things like that. And I could see, maybe posts, things like that. The main thing to get from this example is that we separate our strings, our key names with colons, just to make it a little bit more readable. Now, I have seen people, use 2 colons with their ID number, which is not a problem at all. It's whatever works with you. I've seen some dashes. I've seen some underscores. That's fine. The only thing that I ask is that you use a consistent key naming convention. So throughout 101 and pretty much all of our other courses, you're going to see a colon within the key name. So that's just something to watch out for. Yeah, so strings. What else can we do with strings? We can also play with numbers. So let me actually set, how about the view count? So I'll use view underscore count, and I'll set it to 50. So I'm actually setting a string. So let me get view count, and that will.
You had a little typo there when you said.
Oh no, I saw that. Okay, thanks. Let me redo that. Set view count 50. And I'll press up to go to my history. Get view count 50. Okay. So now I see that I have a numerical value of 50. Now the really cool thing is I can actually change this numerical value. Yes, I can do set view count 51, but that just doesn't really feel right. We can do better. Yes, it's 51 now, but one of my my favorite little commands that we can do with numerical values and strings is incr, which is increment. So increment the integer value of a key by 1. So I just call it incr on view count, and now it's 52. So that's pretty cool. So now every single time that somebody watches a video or something like that on our app, we can actually call incr on that specific videos, string of view counts. Again, yeah, you can check this out on Redis.io commands. It's a great source. It's a great source of knowledge for all of our commands in Redis. I actually go through every single one to read before I do a video, just so I know, all the ins and outs. It shows you history, usage, what version it's for, whatnot. So incr does it by 1, but if say you want to increment by multiple values, like by 5 or 10 or 15, not just by 1, we could do incr by. So increment the integer value of a key by the given amount. So let's say I want to have view count incremented by 5. There you go. So it gives us back an integer value of 57. And this is just going to go continue up, 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 up as we use incr and incr by. So we have incr, we have decr. Decrement the integer value of a key by 1. So decr, view count. I'm not sure anybody can unview things. I guess I should. You should in YouTube, but there we go. So now I dropped it by 1. So based on this naming convention, Suze, what command would allow me to decrement by a larger value than 1?
Decr view count 8.
There's a command.
Oh, did you say by 1 or by more than 1?
By more than 1. Sorry, probably wouldn't. We have decr by. So we can actually decrement by more than 1. So here I'll decrement by 10, view count 10, and now it's dropped our numerical value. So we have incr by. Incr is by 1, incr by is by multiple values, or a multiple number, so like 5, more than 1. And we have decr, which reduces the amount by 1, or decr by, which reduces the amount by our given amount, say 5, 10, 15. So that's pretty much numerical values. And we use numerical values in strings all the time. So it should be, recognized as a valid use case. And just to show you, when I was talking about expiration, let's actually see it in action. So let's say I'm setting our weather in Oakland to, let's see, set weather in Oakland to sunny. And let's just check that. Weather : Oakland. Yeah, it's sunny. So again, like I was saying, how weather changes by hour. I want to expire this if it doesn't get updated. Otherwise, I don't want to give people the wrong weather information if it's, raining outside. So I'm going to call expire. Set a key's time to live in seconds. So I'm going to expire weather : Oakland. And let's see here, 60 minutes times 60 seconds is 3,600. So 3,600 is the amount of seconds I want this key to live. And it said 1, which means okay in Redis. And so I can actually check on the time to live with the TTL command. So TTL weather : Oakland. And so now I have 3,587 seconds until it expires. And that just keeps me honest. So if the weather changes, I'm not going to give false information. I'm just going to not have the information, and I'll have to retrieve that from a weather station or the actual database that is in the background. Yeah. So caches are fantastic. Cache is a great implementation of Redis. A lot of people use Redis as a cache. We're here to actually show you that there are way more use cases than just the cache, but it's a really great start. And we have a couple of videos on caching, so you'll have to check that out. And then let's say that the weather did change. So is that, weather, Oakland. Let's say it's breezy. So what will the TTL look like now that we actually updated it? It actually went away. So when you update a string's value, there's no expiry time on it. So you'll want to update it again. So expire weather Oakland, another 3,600 seconds. Otherwise, it just says, oh, you just updated me, then you don't care about this expiration. So now let's check TTL weather Oakland. And there we go, 3,590 seconds. So, and there are a lot of commands that you can actually use that have the expiration option built in. Because we expire keys so often in our day-to-day business within a database, there's an option you can use. It's usually EX followed by the number of seconds. And as we go along, we'll actually see different examples within the actual RU101 homework and the use cases where we set expirations. So just wanted to get this ahead in front of you before we actually go on to something bigger. Okay. That was a lot of diving down, Suze, into strings. Do you have any questions so far?
No, I just want to make a couple of observations though. So I really love that you explained about the colons, because that wasn't clear to me when I was going through. I was like, oh, why have we got colons? And then I realized, it gets less and less specific as you go to each colon, doesn't it? Yeah. So thanks for explaining that. And also what I noticed while you were typing, which I did not notice when I was playing with it, was on the CLI, when you start typing, not only do you get a little tooltip, you also get, like on the right-hand side, an explanation of what that command does, which is super helpful. I have not seen that in anything before, I don't think. So that is helpful, because when I was going through the videos, I think in the sets, we maybe did like 4 or 5 commands. And then when you go to the documentation, there's like 20 of them. So obviously, you do need to do that extra bit of reading, especially if you want to start using Redis. But when you type them into the Redis CLI, it gives you a lot of help there. When you start typing S, you get a few different options, and then it explains to you what it's going to do. So definitely very useful.
Absolutely, yeah. I love Redis Insight. It's really great for, so a command, you're like, what's it called again? You try typing it out, and then you go even further. You're like, okay, this is great. And it gives you all the different arguments that are required or optional. So it's really helpful. And this is on Redis Insight, but also if you're running Redis from the terminal locally, you do get like a kind of a primitive grayed out template, or kind of like a ghost of what you should put in there, which is also pretty helpful. So Redis definitely wants to help you out. So given that we're good at strings, we're going to actually have a little bit of a movie time here. We're going to talk about hashes. So before, let me remove this from our focus. Before we actually talk about hashes, I want to just give you like a TLDR about hashes. They're objects. So if you use JavaScript and you're comfortable with JavaScript, it'd be like a object or object literal. With a Python, it'd be similar to a dictionary. So an object is basically a container of multiple field value pairs that have some sort of relationship within each other. So at Redis, I'm sure that there's an object somewhere on our internal work database that says name, Justin, occupation, developer advocate, address, Oakland, California. All of these field value pairs or name or key value pairs, those can be used interchangeably, are all regarding me. I don't like talking about myself a whole lot, but it's just I'm here. I'm an example. So all of these details are all contained within one single data type, an object, which is really, really helpful. So if you've ever played with JSON, the JSON object, usually JSON contains data that just all makes sense when it's together. Sports statistics, weather, traffic data. If you're looking up like a product on, some sort of like shopping website, usually when you look at JSON, you'll have data about it. If I was looking up a microphone boom because mine just broke yesterday, it has, weight, carrying capacity, color, how it clamps to my desk, things like that. All those little pieces of information are all contained within the same blob or object. So I'm actually going to play a video that I think is going to better represent what a hash is than me just prattling on. It's going to be our hash video that is on YouTube, but I'd love to share it with everybody if we have some time. And then afterwards, we can actually start building stuff with hashes. I'll stop talking and driving, and we'll get Suze to start making some stuff soon here. So, all right, and here we go.
Hello. Today we're going to learn about hashes, an especially useful Redis data structure. In this segment, I'll explain what hashes are, and I'll show you how to use them to model domain objects in an application. Hashes are collections of field value pairs and look a lot like a JSON object, a Java hash map, or a Python dictionary. Redis hashes are also mutable. We can add, change, increment, and remove field value pairs at any time, not just at the initial declaration. Hashes store field values as strings, which means that they are flat. There are no nested arrays or objects. Also, we do not need to predefine field names of Redis hashes, and as such, we can add and remove fields as needed. While Redis hashes are schemaless, you can still think of them as lightweight objects or as rows in a relational database table. To explore Redis hashes in practice, let's think about how we'd model a player in a fictional online role-playing game, Mages and Minotaurs. In a role-playing game, players live, die, and are reborn, and this cycle of life is reflected in health points, armor, abilities, and battles. We'll store this information in a hash, with every player getting their own hash instance. We'll update this player hash with new information, create temporary fields, and use built-in functionality to increment numerical values and update strings. Enter the player Artexius, the proud elven knight. For this first example, we'll create a hash starting off with the fields name, race, level, health points, and gold. To create this hash, we'll use the command hset. The first argument to the hset command is the key name we'll use to access the hash. In this case, it's player:42. Here we're using a common Redis key naming convention. We start with the word player to indicate what type of thing we're storing. We then follow with a colon and the ID of this player. The colon separates the various parts of the key name, going from least specific on the left to most specific on the right. After specifying the key, we add as many field value pairs as we want. When we run this command, Redis returns 5, indicating the number of fields saved to the hash. We've now created a Redis hash. our first player for the mages and minotaurs. Now let's see how to update and delete fields within a Redis hash. Imagine a player Artexius is having an epic battle with a wizard and... received a thunderbolt spell to the head. In the game, he'll have a status of dazed. To reflect this game state in the Redis hash, we will add the field value pair status dazed to the player hash instance. Here again, we'll use the hset command to add a new field value pair. So the command we'll run is hset player :42 status dazed. What happens when our player no longer has the status of dazed? We'll want to remove the status field from the hash instance. To delete a field value pair from a Redis hash, we use the command hdel. The command is hdel player :42 status. Now the player :42 hash instance no longer has a dazed status, and Artexius lives to quest another day. Getting data from a hash is just as easy as setting it. Suppose we need to retrieve Artexius' level. For that, we'll need to use the hget command. The command is hget player :42 and then the field we want, level. To get all of the fields and values from a Redis hash, use the hgetAll command. We'll run hgetAll player :42. This will return all fields and values contained in the hash. Now, in many role-playing games, players receive gold after completing objectives or defeating enemies. We'll need to be able to increase the amount of gold a player has whenever this occurs. Guess what? There's a command for that. It's called hinkerby, and it increments the value of a particular hash field. We enter hinkerby player :42 gold and the increment value. Let's increment the value assigned to the gold field by 120. Okay, finally, let's talk about the performance characteristics of these hash commands. Most hash commands are O of 1, which means they will always perform a task in a constant amount of time, regardless of the size of the hash. Constant time commands are as efficient as it gets. The hgetAll command is O of n, with n being the number of fields within a hash. This means that the amount of time for the task to complete is dependent on how many fields it has to retrieve. In this case, the n of O of n is the number of fields that the hash contains. hgetAll is practical for relatively small hashes, such as our player hash. For hashes containing thousands of fields or more, it's usually most efficient to select the exact fields you want using hget rather than retrieving all of the data with hgetAll or hscan. Okay, let's review. We've just explored how we can use Redis hashes to represent player objects in an online role-playing game. We've learned that Redis hashes exist as collections of field value pairs. We created and updated hashes using hset. We retrieve data with hget and hgetAll. Fields can be deleted with hdel. Lastly, we incremented numerical values using hinkerby. As useful as hashes are, they aren't the be-all and end-all for object storage in Redis. If you're dealing with nested structures or JSON, check out Redis JSON. Redis JSON is a Redis module that implements the JSON data interchange standard as a native data type. It implements efficient storage, update, and retrieval of JSON data in Redis. To learn more about...
Okay, after that, it's just a bunch of wrap up and salutations. So, cool. So that was a quick little video on hashes, and it was actually one of my first videos. It was pretty great. That was actually in the office in Mountain View in a video studio, not my office. So did that make sense, Suze?
It did, yeah. It was a nice little refresher, actually, and I really like the way you brought that to life with the figurines and everything. You put a lot of drama in there.
Right. I'm glad we actually talked about hinkerby too, or hinkerby. That's actually Guy's favorite command. He says it's the city that Artexius lives in. If you've seen our Redis Live monthlies, there you go. If you've seen our Redis Live monthlies, where we usually just chat about different commands and stuff like that. We like to talk before our meetings and pick the best command to talk about that just sort of sounds fun, like hinkerby or popplepush, or Smith member or something like that. But I'm prattling on. Let's actually create. Have you played Dungeons and Dragons before?
Me? No, it's totally not my bag, unfortunately.
Okay. Well, let's create a new character, and maybe you can join us for one of our Redis D&D games later on. So if you could share your Redis Insight screen, we can create a hash object that represents a new player for you, and I can walk you through it.
Right, let me, because I got so many tabs open here. Bear with me 1 second.
Don't worry. It's funny with mages and minotaurs, we actually get quite a lot of comments and requests to make it into an actual game. So I'm not saying if we get enough pressure from our audience that we'll actually make it, but if we get enough pressure from our audience, maybe we'll be able to do something pretty fun with it.
For some reason, I cannot find the. Oh, here it is. Right. I swear I was not trying to get out of doing doing the work. I literally couldn't see it. Is that big enough for you good folks?
Yeah, that looks good for me. If anybody needs it embiggened, let us know.
Another Guy Royce. Embiggened, yeah. Guy, let us know if you need this embiggened. We know you're on the stream, so yeah, let us know. Right, what shall we do?
Okay, so we are going to create a new player for our game, and it's going to be Suze's character. And basically, we're going to start a new starting character. We'll set a basic level with a beginning amount of golden experience, and you get to choose if you want to be an elf or a hobbit or a tiefling or a human or an orc or a dwarf or a fairy or really anything you want. You can be, a mage or a wizard, whatever comes to mind. But we're all going to keep it all within one encapsulated object or hash that we'll be able to refer to, and it's all going to refer to all of your attributes.
Okay.
All right. So the first command, like we learned in the video, is hset. So hset is basically saying we're going to create a hash. We're going to set values within a hash. And it's just like set with string, only it has an h prefix. So that gives you that affordance that, oh, it's going to be with a hash. So you will eventually, hopefully, memorize all these commands just through repetition. So now we need to create a key name. So we don't actually have to instantiate a key before we actually start using it, which is really kind of cool. With Python or JavaScript or Java, you usually have to say like var, name equals, or you have to say const or let before you start using something like a database. You don't actually have to, they don't have to do that here, which is cool because Redis is just efficient. So let's give you the key name of player : 43. And again, that colon separates player and 43 to let everybody know that we're going to be dealing with a player object and specifically the ID of 43. And now we just start feeding it key value pairs to store within that player 43 object. So let's start with name. And you can do Suze, or you can do some sort of D&D name. Suze is fine. And then for our Dungeons and Dragons race, do you want to be an elf, a human, an orc, a dwarf?
Well, I'm really short, so I don't think a lot of those things are things that I want to be in this game. It's supposed to be like your fantasy, isn't it? My fantasy is to be really tall, so I want to be a really tall wizard.
That's great. Wizards are very tall. They have the very tall hats too. Okay, and then let's start you off with level 1.
Level 1? Okay.
And then let's give you some gold. So gold 20. And then for experience, let's just do EXP. Let's give you 0. So you're just starting off. Okay. So let's check this out real quick. hset is our command. Player 43 is the name of the key. And then name Suze is our first key value or field value pair. And then race wizard is the second one. Level 1, gold 20. and exp0 are all the rest of the field value pairs that we're putting into this object. Cool. And then you pressed enter and we got 5 back, which is the number of field value pairs that were placed inside that hash. So that's kind of like an OK from Redis. So now let's check out our hash. So the command to look at it and retrieve it is hgetAll. And this is going to get all field values within the hash. And then let's plunk in, we'll want to plunk in hgetAll player :43. So we can tell it specifically what to look for. All right, there we go. So now we actually receive all of these back. So we have name, Suze, race, wizard, level 1, gold 20, experience 0. And all this information is displayed kind of like as a list within the Redis command line, but within different clients that you'll be using for like JavaScript or Python or Java for specific web apps, you'll retrieve these in different formats. So this usually comes in as packed as an object, and the client will unpack that as a dictionary for you to use, or with JavaScript as an actual object that you drill into. So basically, visually, when you look at it in the command line interface, it tries to make it as efficient as possible. So that's why you see it as like one long list from 1 to 10. So imagine, Suze, if we had 750,000 field value pairs within one object. You think that would take a long time to retrieve and have it displayed in your CLI?
Yes.
Yeah. It'd be like too much information. I don't know if anybody's ever done this, but if you search too broadly and you just get dumped with a fire hose of information, kind of the concept that we want to avoid, because it does a couple of things. It gives you too much information that you don't probably need. If you're going to display a little bit of information, you don't need all of it. Also, that's going to pull a lot of resources from your database. So it's actually going to potentially slow down or add latency to your database's response, not just to you, but to other users of the database. So hgetAll, while it gives you all the information and that's great, it's good for something small, like a single player in our game. But if you have an object that potentially has a lot of field value pairs, it's actually kind of, this isn't truly the intensity of the word, but it's almost dangerous. So sometimes you'll hear us say this is a dangerous command. And we're only saying it's dangerous because it's going to inconvenience us. It's going to make things slow. It's going to make us, not as zippy as we usually are. Now, there are also truly dangerous commands that might expose passwords or access to people that shouldn't do it. But in this case, this is a slightly dangerous and inconvenient command. So we just should avoid this in production. But for now, just playing with our hashes, it's good to look at. So what's an alternative? If I'm closing a door, I need to open a window. hget. So now hget will let us get something like cherry picking. So let's get player 43's specific gold amount. So you just type in gold and enter, and there we go. And that's all you really need to get. That's all there is to it. And again, hgetAll is not going to explode your database. It's not going to catch on fire. But just be very, very mindful about how much information you're going to be pulling from your database when you use hgetAll. And can you use hget instead to get single or multiple values? Cool. And again, you can use, since the value type 20 is a number, you can actually play with it with the hinkerby command. So let's give you 30 gold for being a good sport and creating a player profile. So let's use the hinkerby command, or hinkerby, and then your player name, player :43. I'm sorry, your player key, player 43, and gold, and then the number. And before you press enter, let's look really quick at that tooltip right above what you're entering. Hinkerby, key, field, increment. And it's giving you increment the integer value of a hash field by the given number. I mean, that's just, I love how helpful it is. And so it just gives you all the instructions on how to set this up. So cool, let's press enter. And there we go. It gives you 50, which is 20 plus 30. So it gives you the total amount back. Sweet. All right.
I like that. I like the fact I've now got 50 gold.
Yeah, pretty easy.
Yeah. Really.
Cool. So yeah, that's pretty much hashes. I mean, there are some more things that you can deal with, but for the most part, it stores and retrieves data in a collection that just makes sense being together. So if there are any questions from our viewers, don't hesitate to throw them into the chat. Suze, do you have any questions or observations about hashes?
Just that error that I made earlier where I asked to get all, but I didn't specify. That was a bit of a rookie error. But yeah, so all very straightforward. I think you just got to remember to put your value in, because if you forgot one, you're accidentally then naming a key, which is the value of the next pair, aren't you? So yeah. Because it's all like in one long line.
Right.
Yeah. But the other thing that I just wanted to say as well at this point is that we are streaming live on Twitch. So that's why we're referring to the chat. But if you're watching on YouTube, you're watching a recording. So if you do type anything in the comments, we might not see it in a hugely timely fashion. So the best way to get hold of us between recordings or even after the series is finished is on our Discord channel, and we will post the link in the chat for you.
Totally forgot about that. Sorry. And yeah, we're always on Discord. So if you have a question about setting a hash or anything like that, we'll still know what you're talking about. So we'll be able to help you, of course.
Yeah, no, I forgot as well. But yeah, it's really easy to forget that we're not just talking to the good folks on Twitch. It's everybody on YouTube at any time, I guess. So yeah.
Cool. All right, let's move on to the next data type. This one's a lot of fun. A list. It's exactly what you think it is. It's a group of things. So I have a to-do list every morning. Feed the chickens, feed the cats, make coffee, make breakfast, wake up my partner, log on to my computer. And that's a list of to-dos. I mean, everybody's done a to-do list for the most part when you're actually coding. But we can store those things in a data structure. Yeah.
Right. Is it about the list in order? Because I really love how you feed all the pets first and get all those jobs, and then you feed yourself, and then you wake up your partner. I love that. All the jobs are done, and then your partner's up. I love it.
Well, my chickens will see me in the kitchen, and they'll yell at me until I actually feed them. So I'm getting rid of the stressors before I can have my oats and coffee.
It's a survival tactic, isn't it? Make sure everyone's fed, and then you can get on with your day.
Nobody wants a hangry chicken on there staring at them.
Or a hangry cat.
Or a hangry cat, for sure.
Yeah, they do let you know, don't they? Yeah.
Alrighty, so for lists, we're going to do the same thing that we did with hashes. So we're going to look at a really quick little explainer video on lists. This is a bit of a vintage explainer. This was actually shot right when everybody was staying at home working. So I didn't have access to a nicer camera. So I apologize for the bit of potato quality, but this is a lot of fun one. It was shot on my phone and a microphone, and I think we did really good. So let's give it a watch. And I'll probably cut out a little early as soon as it starts talking about the administrivia of signing up and stuff. We're all probably already in RU101 right now, so I'll just cut it out. Don't be alarmed.
Hello. Thanks for tuning in to KRDS, Redis's #1 hit station. Join me for a quick intro to lists, one of the many Redis data types. In this video, I'll explain what Redis lists are, how they work, and how they'll help us organize and deliver round-the-clock hits. You'll want to turn up the volume on this one. Alright, so think of a list as an ordered sequence of strings comparable to a Java array list, a JavaScript array, or a Python list. Lists are great for storing strings, but you can also use them to implement stacks and queues. In our example today, we'll be using lists to represent a radio station's playlist. Each playlist is effectively a queue. We'll learn how to add and remove songs, how to view the next 5 songs, and how to see how many songs we have left to play. For our radio station, we'll keep a Redis list called playlist. Each element in our list will be the ID of a song. When adding new elements, we say that we're pushing them onto the list. We push elements onto the right-hand side of the list using the rpush command. Phil Collins' classic hit, Sussudio? That's under the song ID 25, so we'll store the number 25 in our queue. Our command will be rpush playlist 25. Sade's smooth operator, that's 71. Our next command will be rpush playlist 71. Now that we have some smooth grooves all queued up, it's just a matter of removing the first one we pushed into our playlist to know which song to play next. Since we're pushing all of our songs to the right-hand side, we'll remove, or pop, the songs from the left-hand side. The command to remove an element from our queue is lpop, so we'll run lpop playlist. Once we've popped the next song ID, we'll get the song from our database and play it on air. Now that we've stored our songs in a queue, how can we find the next 5 songs scheduled to play? We'll use the lrange command. The lrange command returns elements within a list between a given start and end index offset. Here, we're asking for the first to the 5th elements, so our starting index is 0 and our ending index is 4. The complete lrange command is lrange playlist 04. Lastly, we'll want to ensure our playlist is adequately full of songs. Otherwise, we'll have radio silence. To check the length of a Redis list, use the len command. len playlist returns the number of items in our queue, 7. Okay, let's talk about the performance of the various list commands we've covered. lpop, rpush, and len are all O of 1 constant time complexity operations, so performance isn't dependent on the length of the list. Constant time complexity is as efficient as it gets. lrange is O of s plus n, where s is the distance of the start offset from the head and n is the number of elements in the specified range. You need to be careful with lrange, especially when dealing with extra long lists or when retrieving thousands or more elements. Okay, let's review what we've covered in this segment. We've learned how to model a queue using a list and its rpush and lpop commands. We learned how to get the first 5 elements from a list with lrange. We've also learned how to get the length of a list using len. What will you do with Redis lists? A single list can hold over 4 billion entries. You don't have to rock this jam on repeat. And lists aren't just for what you might normally think of as lists. Need a queue? Just use rpush and lpop. Need a stack? Use rpush and rpop. Traverse a list? Remember, lrange. To learn more about Redis lists.
All right. And there we go. That was that was really fast. That was a very intense little video on lists.
Yeah, I love that radio silence bit.
A lifetime ago, I was a DJ at my college radio station, and yeah, radio silence was the absolute worst because my managing director would come down and start yelling at us like, "You love music. Why is it quiet?"
Yeah, I bet that gives you some good and bad memories.
Yeah, exactly. Well, cool. Yeah, so lists are a lot of fun, and I like how I sort of touched upon near the end there that you can create a stack or a queue within lists, and that's a very common data structure that we use throughout app development. So I won't go specifically into there, but the list structure, the array structure is very, very powerful. And I was thinking we could actually kind of play with our Redis Insight. We're actually connected to the same cloud. Suze has her Redis Insight on her machine. I have my Redis Insight on my machine, but we're just connected to the same exact cloud. I was thinking we can actually kind of play with rpop lpush and see how that works. Sound good?
Yeah.
Okay, cool. So let me hop on real quick. And I will create, can I call it clear? Yeah, fresh new window. So I'll create a playlist, and then we'll show you actually popping them. I'm gonna push them. So let's do lpush Now L push is list push and on the left. So on the left side of the list, we're going to be inserting values. So L push, we'll call it playlist. And you know what? I see that there's a bit of a thing that we should have done in that video. We just entered numerical IDs, and that's fine. But if we're going to be good developers, we should do song and colon. So song colon 25. So this command is going to not just push a song 25 into our list, but it's also going to create it. So again, similar to hashes, I don't have to instantiate them like a variable instantiation or declaration. So I'll just, boop, there we go. So, and then let me look at this list again, just to do a quick check to make sure everything works. And then L range, key, start and stop. Now the start is going to be 0 because we use 0 indexing. And then stop, if you want to go all the way to the end of the list, is going to be -1 because that just goes all the way to the end. L range, oh, sorry, not song 25, playlist.
Playlist.
There we go. And there we go. There's song 25. So if I want to enter more values into my playlist, I'll just do L push playlist. I'll do song 42. I'll do song 89. I'll do song 12, and then song, let's do one more, 23. And you notice that I used L push to push one in, and then I used L push to push multiples in. And that's a great thing about a lot of different commands within Redis. You can use them for one, or you can use them for many, which is really useful. So let me just press up to get to this L range command again. And let me press enter. And there we go. There's my list. Now you'll see how I entered this actually matters. So I entered song 25 first. And so it's at the end of the list. And then I entered song 42 next, which took and pushed that 25 from the left to the right, and it entered itself. And so it's kind of hard to see or kind of hard to imagine, but take the list as you see it up here and then push it like that. So you'll see 23 is going to be the last one that was entered on the left. So 23 is going to be the first element in our list. So it's going to be 23, 12, 89, 42, 25. Cool. And we can verify that by trying, let's do L range playlist, and we'll start and stop with just 0. So 0 and 0. And there we go, 23. 23 is going to be the first element. And if we want to get the second element, we'll do 1, 1, which is going to be 12. So yeah, L range is pretty powerful and it's great. You want to use it if you want to actually get all of the list or pieces of the list. If I want to get, say, this is kind of a fun one. If I want to get the next 3 songs that are in the queue, if I want to display that on my page, my web app, my streaming radio, I'll do L range playlist -3, -1, which is going to go back 3 from the end. And so there's a little bit of weird, cursor gymnastics, but this will tell me what 3 songs are going to be in the queue if somebody was listening to my radio. And so I could pull those up and display like, oh, stay on the radio, you'll hear some Phil Collins or something like that. Cool. Okay, so now let's do some fun stuff. I'm gonna relinquish the screen, and if you want to hop onto your Redis Insight.
Yep. We have the fun and games of finding the correct tab again. I should have just left it on there, but yeah.
Okay, so now let's, I was calling L push, which was pushing into the list. Now we want to remove elements from the list, which is pop. So list always uses, or for the most part, uses push and pop. So now we want to pull from the other side of the list. So we're going to be using an R instead of an L. L is left, R is right. So now lpop playlist is going to give you the one all the way on the right. So go ahead and press enter. And there we go, song 25. So go ahead and do that again. Let's pop all of these actually off of our playlist. Let's just do it one by one.
Oh, you mean one by one?
Yeah.
Okay.
So let's say we played song 25. Now let's say we played song 42, and you can just press up. So these are all exhausted. Okay.
We had 5, didn't we? Let's see what happens when we do it again. There you go.
Oops, now you see it's nil. So that means that our pop playlist is empty. Now we have this extra really cool function that will actually watch and wait until there is something to do with a data type. So I'm talking about this blocking. Blocking will actually wait and look at a data type and will only perform its function on it until there's actual data on it. So brpop is another command we'll use. So let's enter that. And let's look at the tooltip with that. So remove and get the last element in a list, or block until one is available. So it's going to do two things. If there's already an element in the list, it will just pop it. If it doesn't, then it will wait until there's something in the list, and then it will pop it. So that's pretty cool. So it takes a key or multiple keys, and then a timeout. So let's do brpop playlist, and let's give it a timeout of maybe 60 seconds. Cool. I'll go ahead and press enter. All right, so notice that there's no return. It's literally just sitting there and waiting and watching playlist. Since there's nothing inside that playlist, it will return it. Now, let's create something within playlist.
Why have we got an error?
Blocking commands are not supported. Oh, I wonder if it's, Try entering that again. Let's see what happens. There we go. That was interesting. So I just entered that, and you just popped it. So you were blocking, and I pushed an element onto my list on my end, just casually went across the world, and it just popped on your end. So go ahead and do that again. I'm going to create yet another one. So go ahead and call brpop playlist 60, and boom. Wow, that was really fast. That was cool. So I just entered another song into this list, and you popped it off. So that's the power of blocking. So blocking actually works for multiple different data types, not just lists. And you can do different things, like you can pop it and push it onto another list or on top of itself with blocking, or you could pop it or block it onto some other data type, which is really, really cool. Yeah, I'm not quite sure why it said error timing out. I wonder if it's because we were playing at the same inside or something like that. But that's pretty much a list. You either push data onto a list and remove it from the same side, left or right, or you cycle through it like we're doing. So we're creating a list and we're processing it. You'd be the DJ, I would be the person taking the phone calls, taking the request for the songs, something like that. The actual 101 content goes into the list, of course, a lot more. I just wanted to touch upon this a little bit. Do you have any observations or questions that have arisen during this list breakdown?
No, but what I did notice in the videos was that it was really good to have your video, because yours is a supplementary one, like you say, that wasn't part of the original 101 curriculum, but it really complemented well the video that is in the curriculum. So in the curriculum there, Alvin's like drawing out diagrams as to why it's a stack and a queue, and that I think really makes it clear for folks as well. So I really encourage people to check those videos out.
Oh, absolutely, yeah. And I like to do really simple list examples or just data type examples that can get you really into the data type really quickly. The 101 examples are really good because they're much more real world. We're creating, I think, the Redis Olympics in 101. And here we're just, creating a very easy little example. But again, you can put IDs, you can put content, text, numerical values within these lists. So yeah, definitely a supplement. The videos that you'll see that we'll sprinkle in are definitely just like a tasty cookie after a meal of eating, the RU101. Cool. So now we're going to go and increase the complexity of our data types a little bit. If I could do that. And then I'm going to actually talk about sets. Now, sets are very, very similar to lists, but they have one specific. Sorry, let me share another screen. They have one specific difference. They can only contain unique values. So lists, we can actually use multiple of the same value. So I could put in song 25 into our list multiple times, and it's perfectly happy with that. Or I could put in the same numerical value or string value, whatever you want. But with sets, everything has to be unique. So no matter how many times we enter a specific number or value, if the value is the same, we try to add it again, it's not going to stay there. And yeah, let's actually take a look at some quick slides that I created. So we can see that? Okay, we can see that. So, oh, sorry, let me go to the beginning. So an unordered collection of unique elements. So here we have a collection of all the employees within our education team as of like a month ago. So we have Rachel, Kyle O, Caitlin, Guy, Steve, Simon, Lance, Andrew, Kyle, Alex, Suze, Brian, Josephine, and myself. Now, that's a lot of people that actually work really hard in the background. And we'll see all of them as we go by. But so this is an ordered collection. So if we tried to enter another Guy or another Lance or another Kyle or Suze, it'd be like, no, that's not possible. So let's actually take a look at a Redis command to actually perform these additions into a set. Now a set begins with S, so we're going to use sadd. And much like all the different structures of Redis, we're going to use the main command sadd, and then we're going to declare a key. We're not declaring the key beforehand. We're doing it right in place. So sadd users, and then we're going to add Rachel, Caitlin, Guy, and Suze. And it's going to add those to a set. And if we called again sadd users, Simon, Lance, Andrew, and Rachel, you'll notice that I highlighted Rachel. It's underlined. What's going to happen is that command is going to enter Simon, Lance, and Andrew into our set. But it's going to say, we already have a Rachel, so we don't need another Rachel in here. Again, it's not thinking of individuals. It's just thinking of the text values. So if I call sadd again to users and I add Kyle O, Kyle, Brian, and Josephine, those will be added. And then if I call sadd another time to my users and I call Steve, Alex, Caitlin, and Guy, well, Caitlin and Guy already exist as string values within our set, so they're not going to be added in. So it has this very interesting kind of like a filtering effect where you can throw a lot of objects or throw a lot of string values or numerical values at a set, but will only accept unique values. There's a lot of different use cases for that, which is really cool. So there's also a couple different commands we can use with a set. If you want to check if an actual element is in the set, just a simple yes or no, true, false, 1 or 0, we can use the command sisMember or sysmember, as you'll probably hear me say. And so we just simply call sysmember users Simon, and it's going to check the set to see if there exists a string value of Simon. If it does, we'll get a 1, which is yes or true. If it doesn't, we'll get a 0, which is false and no. And you can see that we're calling sysmembers users Vaishali. Now we're going to look for the string value of Vaishali in the user set, and it can't find it, so it's going to return a 0 or no. And then Scard, also a fun command to just read out phonetically. Scard is going to look for the cardinality of the actual set, and that's going to give the quantity of unique entities within that set. So that's going to return 13. Cool. So basically, that was most of the commands to set up and check a set. What we now want to do is kind of play with that data and look at different sets, so multiple sets that are named different things. So this is where sets really are used a lot. We have 3, and set theory is a pretty big thing, so I'm not going to get too far into it. There's tons and tons of videos, texts, and careers made based off of set theory. But we're going to look at 3 of the big ones: union, intersection, and difference. So union is taking all of the different sets and combining them. So a union of all of the movies that Suze has watched and I have watched would be a pretty big list of movies. And we've probably seen the exact same movie too. So we're not going to count that twice. It wouldn't really count towards our larger collection. An intersection is when you take 2 or more sets and you compare them and see which both have in common. So Suze, what's your favorite movie?
Ferris Bueller.
Okay, I've seen that too. Big surprise. It's also one of my favorite movies. So that would be an intersection between the sets of Suze's favorite movies and my favorite movies. And there you go. Also, I was in Chicago. I tried looking for the restaurant where Abe Froman, the Sausage King, went to, but I couldn't find it. Just didn't have enough time. But anyways, now difference. Difference is when you take one set and another set, and you find out what contents of the first set does not get shared with the second set. So, what is your favorite movie that you don't think that I would like? No pressure.
I think it's probably easier the other way around, because there are loads of classic films that I've never seen and people are always horrified to learn. Like, for example, I have no interest in like Star Wars. I'm no interest in Lord of the Rings. I'm no interest in Harry Potter. So yeah.
That's a fun. Okay, let's say, and this might not be true, that you don't like spinach.
That I didn't like
spinach.
Okay.
I like spinach. A lot of people don't like spinach, but I like spinach. So let's imagine that in their difference, that blue section, I like spinach, and I like a couple different vegetables: Brussels sprouts, broccoli, escarole, frisee, potatoes. You might like some of those, which is great and fantastic. We might share some vegetables that we both enjoy, but I like spinach and you don't. So that means that the blue section of the difference would represent my spinach, and that's all we really care about, is the difference between what you like and I like. Kind of make sense?
Yep. Totally.
Cool. And that's basically set theory: difference, intersection, and union. And there's a couple different extras that we can actually play with that just go above and beyond really what we need to go over. Now here is another graphic representation of set theory, and this is dealing with languages and scripting languages and common topics within technology. So skills for Justin, if you look at it: JavaScript, Python, Redis cluster, Redis ACL with our security, Jekyll, and Redis. Simon has, as you can see, JavaScript, Python, Jekyll, and Redis search and C++. And then Suze has JavaScript, Python, Jekyll, and Redis, and is an absolute wizard, as we established previously, with HTML and CSS. So if we want to find out the common skills between all 3 of us, I mean, we could visually inspect, yes, but if we want to do this programmatically and using Redis, we'll use the command sinter, which is set intersection, and then we'll just list 3 different sets. So sinter skills : Justin, skills:_Simon, and skills:_Suze. So it's going to look at all three of those sets that contain unique strings within each set, and it's going to compare the three, and it's going to pull out what all three intersect at. So let's actually see if I could. I'll switch out of this, and let's see if we can actually have you drive within your insight this intersection that we created. So be a bit of typing, but I can call out some of the things we'll add. So do you remember the command to add information to a set?
Sad.
Oh, it's okay. You got it. Yeah, it's sad. SADD. So let's create yours first. So let's do sad skills:_Suze.
Oh, yeah, sad skills. Yeah, totally.
Okay, now let's add all your skills. Let's do JavaScript, Python, Jekyll,
Oops.
Redis, HTML,
Yeah.
and CSS. Cool. All right, so that's happy. And it's giving us a 6, which means that's going to be the cardinality of the skills:_Suze set. So how many unique members? Just for fun, let's try adding JavaScript again to skills:_Suze. So let's do sad skills:_Suze, and then let's do JavaScript. 0. So that basically means, hey, can we add JavaScript to this set? And it's like, we already have it. Only unique members can be inside that skill set for skills:_Suze. Now let's check real quick to see if you have CSS in your set. Do you remember the command for that?
Oh.
We've been going through a lot. Don't worry about it.
Is it something with getting or no?
This one actually isn't get. It's kind of phrased to indicate that it's going to give us a Boolean. So S for set is member.
Oh yeah, sysmember.
Yeah. So sysmember, and then skills:_Suze, and then let's add CSS and see if that skill's there. There we go. 1. Perfect. Now let's see if you what your skill set is for x86. So let's press up real quick, and let's replace CSS with x86.
What is
that's
x86?
It is a very, very basic, close to the metal assembly language. It's nasty. You don't want to look at it.
I just gave everyone a massive clue as to whether that appears in my list of skills.
Down to future.
Yeah.
Cool. So now we see 0. So that is not in your skill set, thankfully. It's a good thing. All right. So we're going to get so many comments about assembly language. All right. So now let's create another set. Let's do one for Simon. So if you want to press up until we get your sad. There we go. So let's
go here, couldn't I? And then go.
Yeah.
Or do we want to go that one?
The difference between yours and his is HTML and CSS with Redis search and C++. So I think it makes sense. Yeah. Nice. And there we go. And again, notice that we can actually put the plus symbol within our Redis command, which is really nice. It just respects normal human language. And then let's add one for Justin.
I really like that you can actually highlight this, unlike in the terminal.
Yeah, it does make it a lot easier.
Yeah.
And so now Redis-cluster and Redis-ACL.
This options button is quite close to the.
Yeah, it is in a way, isn't it?
A little bit. ACL.
Okay. And then, yep. Awesome. Now we have 6 unique entries for Simon's set and 6 unique entries for Justin's set. So now the final, crescendo of this. Let's intersect all three of these. So let's call S enter, and let's call skills : Suze, skills : Simon, and skills : Justin. And this is going to give the intersection of all three of us, our sets of skills. And go ahead and press enter. And there we go. We all know Redis, Jekyll, Python, and JavaScript. That's awesome. So cool. We can have like a nice little meetup and talk about programming languages at some time. So let's do one more. Let's see all the skills combined between Simon and Suze. Now, intersection was only the skills that both sets share. Union.
Yes, I just remembered that. I was like, I visualized your Venn diagrams.
And these Venn diagrams are, I think, are on RU101 as well. And also, if you ever have, if you want to keep these locally, just go ahead and Google search set interactions or set theory, and they're everywhere. So S union skills : Suze, and then also skills : Simon. Now notice that we used 3 sets previously. We're using 2 sets here. S inter, S union, and S diff, they're all variadic, which means that we can use more than 1 or 2 or 3 options or keys. So it doesn't actually care about if it has to be 2 or it has to be 3 different sets to compare with. Just like how we have H set is variadic, so you can have more than 1. It's just little terminology to throw out there. All right, so let's press enter and let's see what all the combined skills are between Suze and Simon. Awesome. Redis, Jekyll, CSS, Redis search, HTML, Python, C++, JavaScript. You can make any site you want. You can do any app you want with that skill set.
The top team.
Go team. Cool. So that is set theory in a nutshell. That's using sets. You can do a lot more, of course, but I don't want to take everybody's time. Time is valuable. So again, this is kind of like a list that is unique, and it is unordered. Yeah. So whenever you get, let's call this again. Actually, let's call the exact same command and see what we get if it's going to be in the same order. Of course, it does look like it, but it can't guarantee the exact same thing. It can't guarantee that the list will look exactly the same. I think because our list is so small that Redis is like, don't worry about it. I got this. But if we have like a 5,000 unordered list, you might get some variation. So if you want to have an ordered set of unique values, then we're going to be looking at a sorted set, which actually gives each entry in a set a weight, and then it will stay sorted based off of the values of that weight. Now, sorted sets are a lot of fun. We're not going to talk about them in this, but yeah, we'll look at them next week and also take a look at them in 101 because it is actually covered within this week's information. So cool. That was a lot of information. We actually have reached all of the data structures, the core data structures we wanted to talk about. Did you have any specific questions about sets or anything that we did so far with those?
Not any questions. No, that might have been the easiest one for me.
Oh, really?
Yeah,
Cool.
I think it was really clear, and also really clear to see why you would only want to count stuff once. And I really like the example that you gave with our team members, because we've got 2 Kyles, which to some people might seem a bit odd, but actually in the company at one point there were like 5 Kyles, weren't there?
Fun fact, yeah, there's a ton of Kyles.
Yeah, a lot of Kyles, a lot of guys as well. There's a lot of people named Guy, not a lot of guys. So yeah, that was quite a common name. So it's quite unusual to have 2 Kyles in one team, which is why you couldn't then put Kyle and then Kyle. You had to differentiate, otherwise one of those poor people isn't going to get counted into the team.
Absolutely.
So yeah, I like that. Yeah,
there's a ton of different use cases for sets, and we do a lot of set theory in our mind that we just don't think about. I went camping last week, And I was talking to my friend. I'm like, I have a stove, I have a big crock pot to cook dinner, and I have a big table I can bring. And they said, well, I have a table too, so I don't have to bring that. You can bring yours. So that's an intersection. And they said, well, I have a huge lantern and I have a canopy that we can put the stove and the table under. So that right there is a intersection of two sets to figure out what all we can bring, or S union too. So the cool thing about a lot of these data structures, the primitive data structures like sets, hashes, lists, strings, is that we really truly do use them in normal day-to-day, interactions. I have a shopping list. I store a string if I'm writing down like a phone number or an address, not a password because we don't write down our passwords, but things like that. That's a string. Hashes. Well, I have a backpack full of things that all make sense. So when I went backpacking or when I went camping over the weekend, everything in there was related for a reason. So it's kind of like a hash. It's a bit of a stretch, but
It's really interesting, isn't it, what you just said? Because, like you say, you're discussing camping equipment with your friends, and we do think about these naturally in our minds, don't we? When we're thinking about situations, we're like, okay, what do we need to do? We're going to apply a bit of logic to the situation. Why would we bring two massive tables and forego the lantern? Like, so we have a nice big space to eat our dinner, but we've got no light to eat it by. And I think that's what people forget when they're programming, don't they? They forget to break down the problem and think, what am I actually trying to do here? And then look for the tool. So yeah, that highlights to me how you kind of have to use the human brain first and then go looking in the commands, don't you?
Oh, absolutely. I mean, when like doing the application planning or project planning, I always love to sort of chew on the data structures that we might potentially use. Just do not have paper yet. Don't even have a whiteboard. No computer. Just talk it out with your coworkers and your colleagues. How would you use this data? How would you expect to use it? Go through an example use case with only using your words. It's a fun challenge. And back when I was actually teaching web development, I didn't have the laptops open for the first week because we would talk about real world use cases and talk about how you would programmatically, approach them. And by the end, everybody was like, are we actually doing web development or are we just talking about philosophy here? But once you have that 100% confidence in the data structure that you want to use, then when it's a really good time to just start using a data structure and see how it works. And the cool thing is with Redis is that Redis is nothing but data structures. So if you're using one for a while and you're noticing, this is kind of weird, I'm butting up against use cases where I might want to have some uniqueness to this list. Well, that's an indication you want to use a set. Or if you're using a hash and you're really enjoying it, but you're noticing, you need to update it more, or you need to store it and pull it from a client, you might want to upgrade to like one of the Redis modules, like with, Redis JSON, which is a lot of fun. Or if you want to search your hashes and search all your data, then you can use Redis search and Redis JSON. But, it's always important, I think, to just start small, start very quickly and efficiently with some base data structures, and then move up and up and up.
Yeah, definitely.
Yeah. And we'll go into some bigger data structures. Like my favorite one is our geolocational data structures, which then allows you to store lat and longitude and then do like distances and things like that. That's my favorite. I absolutely love doing that.
Yeah, good. Yeah.
But that's a teaser for the next one. So yeah, that's pretty much it for the data structures. And I know I missed the first 10 minutes of the stream. I'm so sorry about that. You did you go over homework, or did you have homework questions you want to go over? Or?
So yeah, I basically took everybody through how it works with the assessments. So the quizzes are just a knowledge check.
Okay,
so don't worry about that. The homeworks and the exams are graded. And yeah, I did show a couple of questions. So let me see if I've still got them here. Okay, right. Let's see. Found one. There was another one as well, I think. Possibly not. Okay, let's share this. It's really it's more of a terminology thing.
Gotcha.
but I don't remember it being covered in the videos. So, right, let me unshare share that again properly. For some reason, I was sharing the tab, but it literally just shows that one.
Oh yeah, it sticks to the tab.
Window. Oh, right. Let's get rid of that. Here we go. Right. So, what criteria does Redis use to determine if an operation can be performed against a key? So, I know that a key can be anything, basically, anything you can type into your computer. So, but certain operations can only be performed on certain data types. So, Redis needs to know what type of data it is to determine which operation it is. So, therefore, I knew that I had a good feeling that data type was one of the things. And you can pick one or more answers. So it's either all of them, one of them, or two of them. So I picked data type. I had 2 attempts and pressed submit, and I was wrong. So I had another attempt. I had to think quite carefully about this. I had a strong feeling it was not time of day, and I think that was a little bit of a red herring because we talked about key expiry.
Yeah.
And you don't have to declare anything. It just exists once you've put something in, put a value in there, and you can set an expiry upon creating that value or later on. But if it's past the time of day that it exists, then it doesn't exist anymore. So it's not going to perform an operation on it anyway. So I kind of discounted time of day on that basis. And then, so I was left with encoding a value. And so I decided that it must be data type encoding and encoding a value, but I didn't know what encoding a value meant. So I went off and Googled it. I did get an answer, which I cannot remember now, but given that it was process of elimination, I chose those 2. And then got it right. Yeah.
Yeah.
Yeah, sorry. So there's a bit of like exam strategy there.
Yeah, no, that was very good. That was very good. Yeah, this question is kind of nuanced, and it talks about it in some of Alvin's videos. But basically, strings are reused, and we kind of saw this when we were entering string values like Justin, numerical values like 4 into a key. We can do certain things with numerical values in strings that we can't do with text values. So if we call incr on view count, it will increment that number of views by 1. If we call incr on Justin, the name Justin, I mean, I don't want to get older. I'm pushing 40. So it can't increment a text value. It's not going to tack on a 1 to the end. And so it just says, I can't do that. So it's not only is it looking at the data type. So we store numbers in strings, but it's looking at the encoding of the actual value. So the encoding a value of 4 is an integer. So it recognizes that it's an integer, so it can run an increment on it or an increment by, things like that. And basically, there are more data structures within that store as strings. So bitmaps are actually stored as strings, and there are bit operations and bit fields and bitmaps that we can do on them, and commands that Redis has on them that you can't exactly do on like a single numerical value or a text value, and vice versa. So you basically, Redis does 2 checks. It's like, is this a string? Yes. Okay. Well, they wanted me to do a bit operation. Is this a bit value? Is this really a bitmap? And if it's encoded as 1, then it says, okay, I can proceed. Otherwise, it's like, actually, this doesn't work. So we're reusing strings in a lot of different data types, as you'll see throughout the course. So data type it looks at first, and then encoding, like, are you really a string or are you actually a bitmap or even a geolocational data type? Does that sort of clear that up?
Yeah, and I think that's something that kind of tripped me up at the beginning, which was everything's a string, but when you're learning stuff like JavaScript and stuff, you can't do an increment on a string.
Right.
So yeah, I think at the beginning I was like, oh, what's this? So yeah, it definitely is a lot clearer now. Once you get your head around that bit, I think it becomes a lot easier.
Especially with JavaScript, you can do a lot of really strange things with like strings and numbers that don't always make sense, like concatenating when you should be multiplying or something like that. But yeah, with like Redis, it just tries to keep it as fast as possible. That's their main focus. So that's why they're doubling or using multiple cases of strings as actual other data structures.
Yeah. Let's have a look at a quiz question. So that was a homework question. So that is graded. So luckily, I got there in the end, but also luckily I had 2 attempts. So that was okay. Let's see if this one works. Right. So this is a quiz on hashes. And for this one, I basically didn't, I think I just didn't understand the question. So what I did was I actually typed it into Redis Insight to see what happened, I think. So yeah, we set hash 1 A B C and then incremented by hash 1 B 10. So yeah, I just didn't understand that question.
Right. Yeah, this one's a little also a little nuanced. So let's first do the first line, H set hash 1 A and in quotes ABC. So that first one is going to create a hash with the key hash dash 1. And then after that key, we have field value pairs. So it's going to create a field of A with a value of ABC. So that's just going to create a hash with one entry inside it, A and ABC. And again, just a real quick that those double quotes with ABC, that's the same as doing ABC without quotes. So that's not something that will really trip you up. The double quotes are good for if you have a string value that has spaces within it. Otherwise, you might accidentally create like wrong hash values. So H Inkerby or Hinkerby hash 1 B10. So Hinkerby increments a numerical value. So we're going to go into hash 1. Now we're trying to increment B by 10. Now, based on the above line, H set hash 1 A, ABC, we actually haven't created B yet. But Redis, in its drive to be super fast, super efficient, and very zippy, it basically creates the field value pair B10 on the fly within the command H Inkerby hash 1 B10. So that is that one will definitely kind of trip you up if you don't have a console ready. So if you don't enter it in Redis Insight in the field while you're doing the quiz or the homework, you might think, well, it's not existing, so it's not going to actually create a B or add 10. Well, it actually is, as we see here. So
Yeah. So I would definitely advise people to do what I did and type it in and see what happens if you don't know.
yeah.
And I think as well, it's a case of getting your head around how the information looks when you put it in and how the information looks when you put it out, compared with what you're used to, doing other things in coding. So if I've got a list like 1, 2, 3, 4, some of those things are paired up, aren't they? And you kind of have to remember. So yeah, it makes sense to me now. But yeah, at the time I was like, oh, this is a bit tricky. I'm going to type it in and see what happens. And I think the other way that you could trip up is if you accidentally thought that you were dealing with a set and not a hash, for example. So you might be adding B and 10 to A and ABC. Mm-hmm. Instead, you're putting them all in the same set. So yeah, there's quite a lot of things to remember already in week 1. So that's quite
definitely. And it does take a little bit of time to get used to I really like that you touched on this. Within the command line interface, when you look up a hash and you just get 1, 2, 3, 4, and you don't see any kind of indentation or anything like that, it can get a little tricky. I will definitely recognize that. And it took me a bit of time for me to get used to looking at the raw output of the Redis command line. But eventually, it does get better. You do train your eye to take a look at that. But yeah, it looks, when you first look at it, it looks like a list, but it's actually not. So yeah, you just have to sort of anticipate what you're going to see. And if it looks really different, then you're like, oh, what's going on there?
Yeah, I think it's like any language, isn't it? They all look a bit odd in the beginning, or any sort of thing that you're doing in coding. It all looks a bit funny in the beginning, but then you do kind of get used to it, and then your eye does sort of put things together. So yeah, so the last one that was a bit odd, again, it was a quiz question, so luckily this did not count towards my grade,
Nope.
was about lists. So, and this was purely because I forgot what the commands were. And I got it right, but it's because I forgot what the command was. So with like sets and hashes, the commands start with H and S. So for some reason, I thought that the set would start with an L. So I was like, right, that's not going to create a list. I don't know. I just completely got confused. So I was like, right, we're going to get an error because it's not going to create anything.
Right.
Just slap that down, and I got it right. But that is not the reason why I got it right.
Happy accident.
Okay.
This is a tricky one, though. This is fun. I would actually call this out as a bad naming convention, because we see here set list -4 ABC. When you hear the name or the key list -4, you're expecting a list, right? I mean, I'm guilty of that. I'd be like, oh, we're going to put a list in something called a list. And yeah, set, which is also the name of a data structure, is also the command for setting the string data type. So you have multiple use cases of the word set, and you have the list -4 key name. So you have like a lot of things kind of being thrown at you here as far as like what data type is flying around and being assigned. So set list -4 ABC is creating a string with the key list -4 with a value ABC. So that's going to create a string value, and then the next line, R push list-4 A, B, C, D. Now, R push is the correct command to push elements onto the right side of a list data type within Redis. And it's basically saying, hey, I want to push to the right of this key list-4 4 elements, A, B, C, and D, respectively. Now, you can't push elements into a string value. And this is kind of like where that first question really starts to ring in my head, where it's checking two things, the data type, and it's also checking the encoding of the value. So I think what's going on here is it's first checking the set list-4 ABC, that works perfectly. We have a string in our database. Now, when we're calling R push list-4 ABCD, Redis is like, okay, let me just check to make sure that the data type is a list before I actually execute this. So it looks at list -4 and it sees that it's actually a string, not a list type. And so it's like, oh, I can't do this. I can't push elements into a string. And so that's why an actual error occurs. So
yeah. So I was kind of on the right lines there, because I looked at the commands and I thought, oh, that's not the command I'm expecting. So yeah, I was kind of on the right lines, so slightly on in a little bit of the wrong track, but definitely the right direction, I think, there.
Oh, absolutely, yeah. And like it's always good when you're doing these quizzes, they're low pressure quizzes, and with the homework to have I absolutely love that redis.io/commands. That command page is really helpful, and it's good for like switching between different commands because they know that you're going to be looking at documentation. So I love having that and a command line right in my pocket as I'm actually working with like these quiz questions and stuff like that.
Cool. Yeah. Thanks so much for explaining those ones to me. I'll bring some more next week, I'm sure.
Yeah, absolutely. And for everybody, watching, throw these quiz questions or homework questions or anything like that up into the Discord, throughout the day. We love helping you out. Probably not a good idea to throw the exam questions in there because those are for you to shine. But we'll help you. We won't lead you to the absolute answer with the homework, but we'll definitely lead you to, to set you up for success. So.
Yeah, definitely. I'll be in there too, sharing my whys and also sharing my successes as well, because I did get there in the end with all the quiz questions, and I'm halfway through the homework as well. So yeah, let me know how you're getting on in the Discord for sure. Cool. So that brings us to the end of this week's stream. Thanks again, Justin, for all of that. It was really fun watching all your videos again. They definitely make me chuckle.
Yeah, it's good to go back, memory lane when I had such a little tiny beard.
Yeah, everyone looks so different now, and I can't even imagine going in the office. Like, I don't know when I'm actually going to get to go there and see you. It's quite weird.
Yeah, it'll be great.
Yeah, it will be. It will be good. You'll see that I am actually the height of those mythical creatures in mages and minotaurs. So yeah, that would be strange too, because we're all the same height online, aren't we? It's good.
Yeah, right there we go. Perfect.
Cool. So just a reminder for everybody then, you can sign up if you're watching on the 14th of October 2021. You can still sign up for RU101 until the 26th of October 2021. And then this course finishes on the 11th of November 2021. But the course is always running. So after the 11th of November, another cohort of RU101 will start. So don't worry about that. You can sign up anytime and just join the cohort that is relevant to you. I would advise you, if you want to do RU101 with me this month, sign up now, even if you're not ready to jump in, because just in case you forget, because the sign-ups will close a couple of weeks before the final exam. So yeah, make sure you enroll there, and then you'll be safe to do this whenever. It should take you about an hour or two each week. Or if you want to do everything in one go, you can. I know Justin did that in about 3 days when he joined the company. So it's totally self-paced. You don't have to stick to the weeks. But we are doing this here because I cannot do all of this in one go. So I'm spreading it out and doing it all along with you good folks who are spreading it out as well. So yeah, like we said, we can see you in Discord Monday to Friday. We will be in there chatting with you. So don't forget to join us there. Another little project that we're running at the moment, which is not related to RU101, but it's open to anybody really, is we're taking part in Hacktoberfest. So if you're looking to get your feet wet with open source with documentation or software, please do check out our landing page at developer.redis.com/Hacktoberfest. And for those of you that don't know, Hacktoberfest is an annual event each October, as the name might suggest, which is run by DigitalOcean. DigitalOcean has kindly sponsored this again this year. It's now in its 8th year, and we aim to get folks to start contributing to open source. So what we've done here at Redis, we've got a number of repos on GitHub, which we have identified some issues that we would really love you to come and solve for us. So do go to our landing page at developer.redis.com/Hacktoberfest. And we've put a link there to all of our open issues. Just have a little browse through there and have a go. We'll be drip feeding some more in over the course of October. So if you don't see anything there at the moment, don't worry, come back in a few days. There'll be some more on there. So yeah, we will be back. Me and Justin will be back again next week, same time, same place. Hopefully, I went to switch my lamp on earlier and that just blew immediately. I was like, right, okay, we're sitting here. It's pitch black right now in London. It's only 7 o'clock in the evening. Winter is coming. So yeah, hopefully next week we won't have any technical issues, but me and Justin will be back again on Thursday next week at 9 a.m. Pacific, noon Eastern, 4 p.m. UTC and 5 p.m. UK time. And we'll be looking at sorted sets, faceted search, and big O notation. So I'm really looking forward to Thanks
Big O's
again,
fun.
Justin.
Oh,
Yeah.
absolutely. I love Big O. It's not scary. If you know about it, great. If you don't know about it, don't worry. It's Big O, but it's not that big.
And also, we have had a little gentle intro to it in week 1's materials. So there have been some sneaky graphs in there about how expensive stuff is, and we can see that a lot of the commands aren't expensive until you start doing like the ranges and stuff. So yeah, we've had a little gentle intro. So yeah, we'll see you again on Thursday. But yeah, thanks again, Justin, for joining me today.
Absolutely, my pleasure. Thank you.
Cool. Thanks again, everybody. Look after yourselves. See you next week.
Bye.
Bye.